Okay, I'm going to try to make this video as short as possible, but I want to introduce the 3 maps you'll be making this week and give you a few tips and tricks to make some of the things turn out smoother, such as reprojecting, and also some tips to make your print layout as nice as possible. So the first map, we have quite a bit of data in this Lab 6 folder. You're going to have a geo package as well as some separate layers such as the US cities shape, which is a shape file, and this NLCD raster. So make sure that you know what data layers go with which map. Since you are making 3 maps, and there's a geo package with some of the data inside of it, and also some layers that are not in the geo package, such as this US cities shape. For the first map, you're going to do a land cover, a national land cover data set raster. And what you'll be doing here is simply loading a style, a layer style. When you first bring it in, there will be all of the values, even the no data values. The national land cover data set actually has over 95 values, and this one is going to show all 255, 055. And not all of those values are present in this particular land cover class or area for the land cover classes. And so all of the no data values are black, and we want to remove those, and by adding the symbology from the national land cover data set. So that's the purpose of this map. It's pretty straightforward. Just be aware that when you want to load a style, you can't do it from the layer styling panel that you open up like this, the layer styling panel right here. You actually have to go right click, properties, and then open up symbology to get the style and load the style. And the specific style is unique to the national land cover data set, the colors for each of the land cover classes. So that's why you want to bring in that styling file. Okay, so I would say this is a pretty simple pretty simple project. Let's see, NLCD. The QML is the style file. When you load it, only the land covers that are present show up, and the most important thing is what land cover categories correspond to the colors. That's what gets loaded here. One thing to note, I think the only thing to note really about this map is, we'll say okay. You see how over here it shows those land cover classes as just a continuum, like a color ramp almost. When you go to, if you're using, let's make a layout. If you're using QGIS version 3.2, there are more choices for the way to symbolize a legend for a raster. So let's bring in the map, and then I'll bring in the legend, and I'll show you what I mean. So with 3.2 and not 3.6, this will come in as a continuous color ramp from 95 to 11. You want to change that to categories, obviously. So using 3.2, what you're going to have to do, if you're doing 3.6, it will show up with the categories. It won't show up like this. It'll show up as open water, cropland, developed, and so on. There's an additional step you have to do if you're using QGIS version 3.2. You go to symbology, you click on the legend settings tab, and then you have to uncheck use continuous legend. Okay, so then you say okay, okay, and then it gives you your categories. Okay. So let's go back to our print layout and click off of it and back on, and you'll see that those categories show up. One more, sorry, I remember, one more thing to show you. Some of you wanted to not put the legend right here, but you wanted to put it at the bottom and have columns, and I've shown you how to do columns. So say you make this really big, and you want to put this along the bottom. The way you do that, and this is in this particular case, because it's only one layer and the items inside are can't be divided up, just using this columns this way. Say if I try to add columns, that only works by dividing the layers up among columns. So what we need to do here, we need to go and turn off auto update. And you see how they're listed in this panel right here. You can actually edit each one. You can edit the name of it. But what you have with 3.2 is a way to start a column after the item. See that? So then I go back and I want to make a column above barren, rocky land. Okay, and so I can just make my columns that way. All right, and I can, make my legend be horizontally spaced. Okay, so that's what I wanted to show you with this map. The second map, I'm just going to bring in the same data set, or different, the map 2 data set. The second map is really where the heart of this lab, what I would say the heart of this lab is concerned with, which is how to represent your data using the various symbology modes. So the second map is a census data set, and we bring in some census data. This is organized not by counties. They kind of look like counties. These are actually census blocks, and they are in the Minneapolis-St. Paul surrounding area. See all this dense network right here? That's Minneapolis-St. Paul, and then the urban and rural areas surrounding it. Okay? So what you're going to do, this census block data, let's open up the attribute table, has a lot of information, and this has been, this table has been cut just to show some information. Population of each census block, area of each census, and also the density of each census block, okay? As well as the median income, it looks like. So we are going to symbolize each of these census blocks. Actually, they're gonna be categorized by the density. Like how many people per square kilometer, okay? So because we have a quantifiable column here, we can symbolize in a graduated way. All right. So you're going to go into, so you have your census there. You go into the symbology, and you can't do it with this default single symbol. See how they're all green right now? So you change it to graduated. And when you do that, yes, it disappears, and that freaks some students out because you need to load the value which you want to symbolize with, which I told you was the population density people per square kilometer. Once I put that in there, I have to load classify. And then I get my data. And this is the default color from white to hot red. And you can see the numbers over here. Census blocks with population densities between 0 and 139. 139 is 700, 700 and 153, or 1,530, 1,530 to 2,500, and then 2,500 to 14,000 is just all lumped into one big category. So these are obviously not evenly distributed as far as population density numbers go. They're evenly distributed as far as numbers of census blocks. They're the same number of census block in each one of these categories. This is called an equal count. Okay? So it doesn't really take into account the data and how the data is distributed. It just takes the number of census blocks. And how do we know how many of those are? We can go up to the attribute table. There are 2,464 features in this layer, meaning 2,464 blocks, okay, represented here. Okay, let's close that out. It might not look like that, but there are a lot of small ones in here. Okay, so here we're representing it in a graduated, with a graduated style, using the value population density people per square mile, kilometer, excuse me. The thing that I want you to focus on here is the different types of modes and how it changes the data distribution. So this is equal count, where the equal number of census blocks are in each one of these categories. Equal interval takes the values of the population density column from 0 to 14,000 and divides it in 5, because we have 5 classes. Okay? And so what it's doing is that it's taking that value 0 to 14,000, dividing it in 5, and showing the census blocks based on 5 equal categories of population density distributed evenly between 0 and 14,000. This is actually not as good to show this data as the other way, because you don't start getting really dense populations until you're right in the city, right? So it looks like most of these census blocks fall within this first category of 0 to 2,800. And that's why most of this map is white. And not until you get into the heart of Minneapolis and St. Paul do you start to get these really high density census blocks. How do you know that? Well, you look at the histogram, okay? And I introduced this in the directions. Histogram. So you will look at your vector layer histogram. If you don't have this tool, this little has a little processing toolbox symbol. You need to load it. You should have it. It's a default processing toolbox. You go into plugins, manage and install. Installed. I have way more plugins than you guys will have. And then make sure your processing toolbox, check it on. If it's already checked on, check it off and check it on. And then close. And you should have, when you're done, a little processing toolbox symbol. Okay, so we want to look at the histogram from the census layer for the column population density. Change the number of categories to 25. And what this is going to give us is a link. Hopefully it'll run. Okay. So you click on this link and it opens up your histogram. Okay, this is population density per census block. This is number of census blocks. So you'll see the number of census blocks is much higher in these low population density numbers. Remember I showed you around 2,800 how low it was? That's why you don't have a lot of data out here to symbolize. So using the histogram is really the best way to evaluate how to display your data. Okay? Hi, I'm recording a video because I'm getting questions. All right, so you can edit these modes and see which one of these modes seems to give you the best display of your data. Check and see how it breaks up the data over here when you look at the values in the categories. Natural breaks is also a popular one. Okay, you're going to use a different color ramp. And then go back to the equal count and look at the data for the equal count. Okay, the equal count really emphasizes those low density, kind of brings out the most difference in these low density areas. You can even go in and edit these values by double clicking, lower value, upper value, and do your own custom values. Okay, so that's kind of the meat of that, is discovering ways when you're using a data set or an attribute that has integer values or decimal values, some kind of interval where you have numerical data, of symbolizing them and then choosing the best way to symbolize them. Okay? All right. Second thing about this map is bringing in the cities. The cities, for some students, were not showing up. One, they weren't showing up directly on top of the layer. And you'll know because when you bring it in, they won't show up as little dots everywhere. They'll show up displaced because they are in a different projection. They're in 4269. If this happens, you can shut down QGIS after you've saved your project, start it up again, bring the US cities layer in again. Okay? Or you can open up a separate project that you use just to reproject the US cities into 26915. Okay? So we're going to do that really quick. I'm going to It worked, but I want to show you what that looks like. I don't actually want to save this project. So we're going to discard. Okay, my 3.2 will take a while to load. It'll take a long while to load. Maybe I'll clip this out.